So, and also you can apply with some of the hidden layers you want to be specified, like any kind of the dense layers or max pool layer, fully connected layer. And also you can specify different layers we discussed in the RNN section also. So that you will get somehow to learn training of the mechanisms iteratively in your hidden layers, to learn your weights and also computing the loss. So max pooling layer, if you want to be tune your image to in terms of resizing of the image. Similarly, the fully connected layer and output layer, you want to be specified output layer specifically for binary class classification task. And for multi-class classification, you can specify the categorical values or categorical nature. Similarly, the regression task you can also specify with respect to that. And activation functions, we have so many, so we're going to be learn maybe the upcoming classes. But you can say as of now, activation function is a firing kind of the nature. Firing kind of the nature. So we have seen whenever you have optimizations, or you can sort activation function is going to be differentiable, then only we are going to be used in the back propagation algorithm. We have learned this one. So here also we can apply the activation functions with respect to whoever having the differentiation functions. So whoever don't have the differentiation function, it may not be compute the losses and also the accuracy values. And further, we use epops obviously to compute in term training with respect to the forward and backward propagation. So for each and every one, we're going to be computed with respect to 10 epops or 1 epop, even 5 epops, so that it will run iterative process with respect to all the hidden layers, and also uh, from up to you can say the output layer. You can say whatever the output you're going to be mentioned. So let's also play around with this data set. Yeah, this is how this is going to be do. We are having the image with respect to the pizza, it's going to be identified with this pizza or the steak with respect to the hidden layers what we had. Yeah, so let's play around with this, and we will also more focused tomorrow maybe. Yeah, you can see here image data generated with respect to these grayscale images. So is going to be converted whatever the grayscale images we had. I'm just passing this grayscale images to understand to generated the new images. Yeah, so just applying some CNN without generating that also, so that you will get some idea how does that going to be helpful. Yeah, you can see the batch size. I'm just passing number of images to process at a time, and also the target images what you're going to be learn. So we just now learn why we are using the padding, striding, just to ensure this. You can see just to ensure this target size. That's it. So you want to be encounter with the 4x4. So the if you're having the 5x5 and 2x2 kind of the thing, you cannot multiply this, right? So at the time you can add the padding and to get the multiply and to get the results in terms of the 4x4. So like that we are just to going for the discussions of 224 224. So for our input image also having the 224 224, so it's matching, then we cannot do any kind of the padding results at the end. Maybe you can use in terms of your, you can say, a convolutional layer, that is fine. Similarly, we can apply with the training data sets and testing data sets. Then simply apply. You can say the CNN layer on top of your data sets. Training data sets. You can see the kernel size along with the activation function, input type, and convolutional 2D with respect to the max pooling. This is a some hidden layer, and with respect to pool function, you want to be specified. Padding, if you want, you can specify it as a valid. Otherwise, you can mention it as a false. And convolutional 2D with respect to this, these are the hidden layers. I can say these are all hidden layers up to this max pooling. So this is a flat end. It's going to be give as an array at the end. This is the output results you're going to be get in terms of the binary or multi-class classification task. Then you can compile and test your data set according to whatever you have learned by using these hidden layers. So we'll go and check out this maybe tomorrow. So we're going to be learn all the different models I'm going to be apply in this case study. So this is very brilliant idea. I can say whenever you learn some any concept with respect to the image processing, basically what will happen at the end, you have to be classify this image, or you want to be regressively understand this image in terms of binary class classification or multi-class classification, or even for that matter objective detection. and something called as I can say pose detection. Suppose you want to be detect some of the pose like hungry, angry, sad, happy. So this kind of the pose, you can say this kind of the facial expressions you have to be understood. So for that we have also different concepts to learn. So I can say CNN is not related to only one objective or one application, not only for one applications. So currently we are learning only for the classification task with respect to input images you have, but we have so many other applications like this: object detections, pose detection, identifier recognition. Okay, and something called as, you can say, if I give a image, it will tell who, what are the different objects we had and what are the different elements we are going to be underlined with that. So we can also call it as maybe that object I can say object identification. Object identification. So at the time it's going to be learned, you are going to be sit at the chair, some blue sky is there. So you're going to be get as a result kind of the thing, a person is sitting on the blue sky. So like that you were going to be get some meaning nature while you giving some image, input image like that. So object identification, this is also very helpful to understand as a one of the applications. So we have so many applications. We can also get face recognition, like video, live video face recognition, whether you are a male or female. And something called mask detection. Nowadays they are using police transport, police, traffic police, and they will also get some of the good revenue by using this. If you don't wear a mask, they're going to be make it as a fine for you. Even though helmets also, right? Helmets, whether you wear a helmet or not, is automatically detecting nature, but according to the computer vision concepts you're going to be learn. So these are some of the concepts with respect to the live analysis and with respect to the training data sets and testing data sets. Maybe we can learn this tomorrow. So I will also share these notes with you.